Hello everyone, it's Brendan. What I've got for you today is a quick video describing how to do a halogenation of an alkene to form a vicinal dibromide. So what we've got here is going to be the case where we just have an alkene, and I'm going to draw the simple alkene that I pretty much always draw. And it's going to be reacting with Br2. And it's going to form vicinal dibromide. So in order to help you see the stereochemistry of this reaction, I'm actually going to draw it a little bit differently than I normally do. So what I'm going to do is down here, I'm going to use wedges and dashes to help show you the stereochemistry of this group right here. So what I'm going to do is you just want to imagine that you're taking this molecule and you're bending it 90 degrees away from you. When you do that, because we're rotating it about the double bond's still pretty much going to be in the same place. But now these groups down on the bottom are going to be on wedges, and they're going to be coming out of the plane of the page or towards you. And the groups that were on top before are going to be going into the plane of the page or away from you. And I think it just makes it a little bit easier to see why this ends up being an anti-addition reaction. Remember, anti describes stereochemistry. Basically just tells you that one of the groups is going to add to the top and one is going to add from the bottom. So let's go ahead and get started. So let's say we have this group reacting with Br2. And what's going to happen is the alkene is going to open up and attack the bromine. And at the same time, this bromine is going to come back and it's going to attack one of the two carbons across the double bond. Now, when this happens, that needs to break off as well to make sure that otherwise they would still be attached, and that's not the intermediate that we look to form. And what's going to happen here we are no longer going to have the double bond because that double bond has hinged open. But pretty much everything else is going to be the same. What I'm going to do is I'm going to draw this in blue, and I'm going to draw the other one in red, just so you can see where they came from. And this bromine is going to have a positive charge on it, and the other bromine that kicked off and took the electrons with it is going to have a negative charge on it. So this is what we have. This is what we call a tribromide intermediate, or it could be a trichloride intermediate, just depending on which halogen you use. And what we have to ask ourselves is which one of the two carbons is this bromine going to want to attack? And in order to best understand that, we want to think of this bromine not as being a rigid bond, but kind of moving back and forth. It's it's kind of like doing the robot. It's got a little bit of dance action going on. And what happens is when it leans over to one direction, you can think of it as leaving a bit of a positive charge away from it. It's vibing over here, leaves a little bit of positive energy over on this side of the dance floor, or it vibes in the other direction and leaves positive energy over on the other side. So when that happens, there's one of two ways that it can go. It can go to the left or it can go to the right. A lot of times you don't have to draw this intermediate, but I'm just going to show you what it looks like anyway. What it's going to look like is a positive charge here, or maybe a partial positive. A lot of textbooks will draw it that way. And this is a bit less than a full bond now. It's more of a half a bond because of it's leaning over to that side. And now, or it could lean the other way. I'm not going to draw the other case because that's not what happens. It's going to want to lean to the side that's going to leave behind the more stable carbocation. So that's going to be the positive charge or the partial positive charge that is closer to the carbon atom or on the carbon atom that is more highly substituted. And for that reason, it does lean this way, the way that I have drawn here. And what that means is this bromine, this negatively charged bromine that's floating around, is going to be able to attack that carbon atom right there. Now, when it attacks that carbon atom, it bumps these electrons over. It has to bump those electrons over because otherwise it'd be violating the octet rule. And I'm going to go ahead and eliminate this because this really is not part of our intermediate. It's just to help you understand why it does what it does. And what we're going to end up with, notice the bromine attacked from the bottom when this bromine attached to the top. And so after it's all said and done, we're going to end up with this bromine over here, and then this bromine down here. Can't forget about that methyl group. And that's it. That's basically what happens. Now, just as easily as it added with the left bromine up and the right bromine down, it also could have added with the left bromine down and the right bromine up. It's just the initial step would have had to attack from the bottom. There's equal probability. The reason there's equal probability of coming in from the top or the bottom is if we look at this initial alkene, each of the carbons are sp2 hybridized. sp2 hybridized means that it's a planar structure. It's a trigonal planar geometry. And because it's planar, it easily can come in from the top or the bottom. There's no difference. There's no preference, no sterical hindrance. And that's why, the opposite of this, with this bromine going down and this bromine going up, could just as easily form. Thanks for watching. I hope you found this video helpful.